Huh? Negative. Yesterday was a whiteboarding exercise, yeah. So what the V8 engine is basically a combination of JavaScript code and C libraries, or C modules. And in that way, you can have this JavaScript environment that is running, that can run a server or something like that, but that can also do things like communicate with your file system, right? Can actually communicate with other pieces of your computer. And so that's the really magic part behind Node, is the fact that it's JS. It's still just JavaScript, but it's running C behind the scenes to do the things we're used to with a low-level language. So with that, Node is extremely powerful. Again, Node is built on top of Google's V8. So you can find some information for V8. V8 actually also runs in the Chrome browser. So this is something that's used in a lot of places. V8 is just a general JavaScript runtime because it can do so much. There's also something called libuv that is part of Node, and it's basically just a way for us to have easier API calls to, again, other functions. There's a couple different packages that comprise Node. But what this nets us in general is this server environment that has a lot of capabilities. Now, with Python, we talked about, or with Java, for instance, and we talked about pros and cons to each stack, right? You know, what a use case is for this or that, right, for each of these technologies. So in your reading from yesterday that everyone did, is there a specific use case that you came across for Node or something that Node would be good at? Does anyone have a guess or an idea? Like what kind of project would play to Node's strengths? Yeah, any idea? So commonly what we describe Node as, since it really takes advantage of one of JavaScript's core features, which is an asynchronous nature, the ability to write asynchronous functions, is Node is really, really good at rapid communication. Rapid communication that even nowadays is actually real-time communication. And that's the socket stuff. We'll get into that later. But it facilitates this very easy way to do real-time communication, which is actually really cool. The difference between pre-2000 web versus 2000 plus web, as far as what happened when Ajax came about, was monumental, right? We refer to that as Web 2.0 because it was such a shift. WebSockets in general, at least in some people's mind, is that next big shift, right? Because how does the HTTP request response cycle really work? Can a server just talk to me out of the blue? Not really, not typically, right? A server has to wait for what? The request. Yeah, a server has to get a request to know, hey, this person wanted this thing, I'm going to now communicate back to them. But before WebSockets, that was the only thing that we could do. With WebSockets, which is something that Node really kind of champions as being one of its big selling points, you have this ability to keep this connection open. And the platform describes this almost like a phone call versus a text message, right? I mean, yes, I can text you, but I'm waiting for you to text me, I'll text you back. Waiting for you to email me, I'll email you back. Whereas a phone call, I mean, we can sit and talk over each other all day long, right? And there's no, exactly, it's seamless, right? Sometimes people talk to me for too long on the phone, oftentimes. But it's this seamless communication. So that is one of Node's biggest strengths. Another really cool thing that Node does versus maybe some of the other servers or frameworks is that it is asynchronous. What do you think the benefit, right? A server's ultimate job, right, is to do a request, or is to get a request and to build a response and send it back out. What is the benefit to being able to do that asynchronously? To say, I hear a request, I hear a request, I hear a request, maybe without responding first. What's the benefit there?
You don't have to wait.
We don't have to wait. It's all non-blocking, right? If I say, okay, you gave me a request, I have something that's waiting for a response to be created, but in the meantime, I'm going to go on to Hector's request. I'm going to go on to anyone else's request, right? And then, okay, along the way, now this response was built for you. That finally comes back out, right? Suddenly, you have this way to immediately spin up, or not spin up, but have the ability to hear many connections simultaneously. Many requests can be created simultaneously. If you look it up, it varies depending on the actual, how much memory is allocated to each one of the requests, but it borders on, it's around 200,000 simultaneous requests, which is pretty exciting. Now the way other servers, because other servers obviously handle 200K users, right? It happens, but there's different things you have to do. You have to spin up multiple instances of a server. They actually use multiple threads on a server, so the computation is increased. Node kind of gets around that because of the asynchronous nature. It's just using a little more memory and it's saying, hey, we'll go back to that, we'll go back to that, we'll go back to that. But what we call it is non-blocking, right? No action actually stops us allowing more requests, which is really cool. So those are some of the pros, right? And the biggest thing with Node and then with Express is it's just also very, very easy to spin up a way to interact with the database. So when you want to create an API for a project, honestly, Node and Express and MongoDB, it's like 10 minutes and you have a working API. I'm not even kidding. Like at this point, it's going to take a little bit longer, right? But when you guys are used to it, 10 minutes working API, your backend is done. Not with all the authentication and all those other layers and middleware that we'll add, but at least for having a database like we would in MySQL and having something interact with it, you can do that in 10, 15 minutes, which is really, really cool. And you'll have to do that during the exam. Let's talk about some of the cons, though. Does anyone have an idea about maybe a con when it comes to Node or something they've read? Not many. Logic? Yeah, we should not really put heavy lifting in the actual Node server. It's not good at doing computation. The way that Node works, again, it's designed around this idea of rapid communication. But if you're doing something like trying to, crunch a data set and produce some result or aggregate some information or do something like that, Node is really not a good candidate. Because what happens as soon as you try to do that process actually starts to block the other requests from coming in. So anything that's like heavy computation, you don't really want to use Node for. Now, obviously, with everything, there's kind of an asterisk, right? Like you can still use Node to do those things, but instead of Node processing those things, you'd usually kick it off to something else, right? You'd maybe then send a request to your Python server that is running this type of library that can do the computation. Or actually, some of you are now familiar after the hackathon with Lambda functions. A very popular use case of Lambda is to say, hey, Node can't handle this, but I can spin up a Lambda that can handle it and send me a request or a response back, right? And the asynchronous nature of Node, just waiting for that response, that's it. Exactly. We're dispatching events. We can dispatch events and things to do for other pieces of technology. So even though it has that hurdle that it itself can't do it, there are still ways to get around that. But that is one of the cons. So pros, really you can kind of sum it up as this: any sort of rapid communication, a lot of instantaneous connections, instantaneous air quote because nothing's instant, but instantaneous connections and a lot of them, right? Versus not really having the ability to do a whole lot of heavy lifting. So Node is great for certain applications. Now, someone mentioned chat, right? Chat is fantastic. Serving up something like an API. I mean, I would say Express with Node and Mongo is probably the most popular API out there. You can make an API in Java. You can make an API in Django. It just takes a while, right? But Express, 15 minutes. What's up?
So does Node take much resources to hold on to the long communication?
It uses too much of the working memory because Node wasn't designed to do heavy lifting. It's just designed for the sort of rapid retrieval of, the rapid communication. That was its big selling point. So because of that, it's not optimized to do like computation and things like that. But again, you can still just dispatch that to someone else. But yeah, it's not designed for that. So you will see it slow down. You will see it bog down. Yeah. Well, let's get into it. So like I said, today's going to be kind of more of a demo than anything. So you'll have to walk through the platform when it comes to installing Node and get Node installed on your system. It's going to be different directions for Mac and PC. But once you do have Node installed on your system, it's actually pretty cool. Just like we can write Python and open a Python shell, we can actually write Node and open a Node shell. And really, this is a place that I can just run JavaScript, right? So with running JavaScript, I can console.log, hello from the Node shell, and we can see that statement printed out, right? So nothing too fancy here, but just to show you how it works on your system, it is this now Node JavaScript shell that will run JavaScript, right? Well, just like Python, right? I'm not going to open a Python shell and write a Django project here. I mean, maybe you can, but you're an insane person. Please don't do that. You could write a Node server here. You totally could, but please don't do that. we want to reuse these things, right? So what we want to do is we want to create a directory, and then we want to start a project, okay? So this is just going to be a simple rundown of a sort of hello world from Node. So make dir hello node and cd hello node. Okay. Just to kind of give you guys something to compare it to, the way Node will feel is the most similar. The way Node and Express will feel is the most similar to like Flask. How you did Flask. You make the entire structure of this project yourself. You know, when you get into Angular, that's more out of the box. You know, everything's included. Node is very much batteries not included. That's the whole purpose. It's very customizable to a specific use. So what we'll do is we'll just create what will be our main logic unit, just app.js, and we'll leave it as that. And let's open this up in my editor of choice. All right, so app.js. So we talked a little bit about the responsibilities of a server, right? A server mainly does what? It listens for request, if I can type, and then it does what? Sends a response. Now, what can that response contain? We kind of talk about the big three, right? HTML, CSS, and JavaScript, right? Jesus, I cannot type today. All right, HTML, CSS, and JavaScript. And with that, I mean, let's kind of go through a timeline for a moment. When you guys were back in WebFun, right, and you built a index.html, and you had it in a folder, and then you just told that index.html to reference styles.css, right? What happens? How does styles.css actually show on that page? Do you guys know?
Put the link of address of
Yeah, we put a link. Does that create a new request for us?
No.
It does. It actually does. Every resource, every script. Well, we will get to it with Node, but just in general, anytime you have link, anytime you have script source, anytime you have a CDN, it is making a request to that server or that resource, right? When you had it local on your computer and you were just opening files, we weren't serving anything up back in WebFun. You were literally just using your browser as a glorified Microsoft Word, if you will. You were just opening a file there. It's still new to try to make a request, but then your browser knows to just look in a directory. Look in the directory for that current project or for that current resource. Well, when we're serving something up with a server, it's very different. Back in Django, we had to use the actual templating engine to say, hey, find out where that resource is, generate the URL, and then it'll make a request to your server to tell your server to find that resource, right? So there's a bit more going on than just saying, hey, grab that stuff, right? It's actually a request to a server. Now, the reason I say this is because, again, Node is very batteries not included, meaning out of the box, there is the capability to talk to your file system, but it's not here. We have to write it. There's the ability to read a file and generate and digest what it is and send it back to the user, but it's not included. We have to write all of that. So you're going to see a lot of syntax here that will not make a whole lot of sense in the beginning. And I'll kind of dig into what is actually happening, okay? But we listen for a request, we send a response that's containing these three. Somewhere along the line, we actually had to traverse a file structure to grab the file, to encode it properly, to send it back out to the user, right? So let's get started here. What we need to do, first of all, is we need to say, hey, I'm going to be using something called FS, which is our file system. It's Node's way of communicating with the files on your computer. Again, Node kind of has the ability to use C or WebAssembly to do a lot of the things on your actual hardware. So the FS is part of that capability. We also want to pull in something called HTTP, which is, believe it or not, our server. We will create our server using this HTTP module. So FS and HTTP, and we'll just put a little comment for grabbing files and to create. Oh my goodness. All right, sorry guys. All right, so we need that FS to grab the files. We need the HTTP module to create the server. Now we can actually define a server. Var server equals http.createServer. Now this create server will take in one argument. Does anyone have a guess what it might be? Stop it. Callback. It will be a callback function, right? We're going to send it our function, which is actually all of the logic for our node server. So we will send it a callback. Does anyone have a wild guess as to what 2 arguments this function will take? Think server. What 2 things does a server really do? Request, response. Request and response. This callback function gets both the request and the response from the create server method. Create server says, okay, when a request happens, I'm going to send it right to this callback function to figure out what to do with it. I'm also going to send a response object so that callback function can build it out and send it back to me. Send it back to the user, if you will. So really, if we just now console.log the request, let's take a look. Now, just like we had to do back in Flask, we actually have to turn our server on, if you will. We just have to say server.listen. And we provide a port number to listen. Listen on 8000. And we'll just give ourselves a little statement. Console log on 8000. So this right now is technically a working server. It'll probably error out because we're not doing anything with the response, but let's see if we can run it. So I'll say node app.js. We'll see on 8000. Let's try to make a request. And we'll see it hang, right? No response is coming back. The system is not sure what to do right now, but let's shut down our server. Oh, check this out. A lot of information in the request object, right? That is all the request. Now, there are a ton of attributes on this request, and we're not going to go into all of them, but what might be an important thing to read from the request right in the beginning to know what the heck to do with it? We just know this is an HTTP request, but what have you had to do in your other stacks so far? You get a request. What's the next step? What's the URL? What is the request, right? We have this object. Let's read the URL. Request.url. And let's spin node back up again. Just like Python calling Python server py, we're going to call node, tell it to run app.js. And we're on 8000 again. Let's refresh the page. It's still going to hang because there's no response coming back. But check it out. Slash. The URL is just slash. Well, let's go to slash, Patrick. And we can see a slash Patrick, right? So the request.url is a way for us to very easily read the URL. Well, you might say, well, wait a minute. Is there no routing? Is there no, module that's built to, have our URLs in it? Is there nothing like that? I can't think of the Java equivalent, but the urls.py file, right? Is there nothing like that? What do you think you have to do in Node? Build it yourself. That's what I mean to say when Node is not, it's basically batteries not included. So if I can see that the request, or I can see the request URL, can I just do a simple if statement? If the request.url equals, what is this a symbol for? We call this what? Routing. The index route, right? Or routing in general, but the index route or the root route. So let's console.log. We can just do something like index. And we can also create a response. So this is where it's going to get really granular. We can create a response, but what you'll have to do as part of it is to write the actual headers for the response. Now, some of you might have heard of HTTP headers. What it is it's something that's sent alongside the HTTP response, and it basically just helps your browser or the system understand the status of what happened, the encoding type, like what kind of data is in this transmission, and basically any cookies or middleware or authentication sent alongside the response as well. But ultimately, the essence of it is just telling your browser or whoever requested it what the heck is coming back before it just gets data, right? Your system might not know what to do intuitively. I mean, browsers are smart enough nowadays to try to style what looks like HTML. They'll try to still represent that text on screen, but if you can give them a heads up as to, hey, this is text CSS or this is text HTML, your browser can more easily understand that. So what we'll have to do is we'll actually have to create a response. Response dot, and we can write the head for the response, and we'll send a 200 code. Does anyone know what 200 means? Does anyone know what 404 means?
Yeah, is not found.
Error, file not found, right? 404. So 200s are okay. 200s and 300s are okay. 200s is all good. 300s is redirects. 400s is client made an error, like they tried to get something that wasn't there. And then 500s is server level errors. Those are the bad ones. 400s is fine. To send back 400s whenever you want. But ultimately, you want 200s and 300s. You want this was okay or this was redirected. And so what we can actually just write the head as 200. And then let's see what happens if we just do response.end. End the response. Let's see what we get now. Spin our server back up. Let's, let's try another experiment real quick. Oh, did I? Oh, is that okay? Gotcha. Ahoy. This was great. I have debuggers on the fly. It's nice. 20 people reading your code. So we saw index get printed out. We didn't really see anything appear on the screen, but check it out. It didn't hang this time. This is error because of my browser, so don't worry about why the A is there. But we are just getting a response. It's just saying, hey, this is fine, right? Let's try to send back a 404 and see what happens. And I'm going to have to shut down my server and start it again. And we see our big fat 404 come back. So we are sending back that error. Not found, right? You'll see that 404 is not found. Let's send back a 418. Now let's shut down our server. And I'm actually going to introduce you guys real quick to one of the first things that you'll install using NPM, which is very similar to pip. It's a package manager, but for Node. And you can install something called NodeMon. And it's really cool. You install it globally. What it is, it's a Node monitor. It will tell Node to run a file, but also monitor that file for changes. And if there are changes, to automatically reset itself. So in that case, I don't have to keep shutting down the server, starting again. I can say NodeMon app.js, and it'll run it. And this is just the information about NodeMon watching that file. And if we send back 418, we get the I'm a teapot error, which is my favorite HTTP error response. I don't know why it exists. It just does. All right, so we can send back responses, right? But what good is that without data, right? So let's say as part of our response, we've written the head, which tells our system what is coming through. But let's change it up a little bit. Let's send back a 200. Let's say it's all good. And then we can send back this object, which is the header itself. And we can tell it that, hey, you're going to have some content coming back that is going to be of type text HTML, right? Again, the header's just informing the browser what the heck this is. Your browser will still try to work with it regardless, but this is the best way to do it. Right? Does anyone have a guess what I can put in here? HTML. So check it out. So we're getting a request, which we already saw that we can dig into, that there's a ton of attributes and information about, identifying the user, identifying what they wanted, identifying any cookies sent along the request. But all we really care about at the moment is the URL. Did they want this thing? Did they want that thing, right? Then we say, let's take this log out. We are writing the head, which is our headers, to basically inform our browser what the heck is coming back with the response. Then we are writing data to the response itself. We are writing a little h1. Does this seem scalable? Do you think that ultimately we'll keep writing our HTML in the middle of this .write function? No. We're not going to be doing that forever. This is more to show that we can if we want it, right? That under the hood, this is what is going to continue to happen. So let's check to make sure that NodeMon restarted. It did properly. And we have an H1 that is now sent back from our working server. And we controlled pretty much every single step of the way, right? All that Node did for us was allowed a response to come through, and I'm sorry, allowed a request to come through and gave us a response object. We define what the object looks like. We define its headers. We can define all of its attributes. We can send the data back, right? So now we have a way to have a working server. How can I make another endpoint, right? I have an endpoint that is indexed now, right? I'm sorry, I refer to this term endpoint because I consider it an API, but a URL, right? So what's another URL? Let's make another one. Someone shouts. Patrick? Let's do Patrick. What did you say? Else if and then what should we do? Yeah, let's just copy this whole chunk, right? We're probably going to write the head regardless. It's going to still be, let's say, HTML. Let's just put my name there instead, and let's still end the response there. So let's check this out. All right, it reset. We can still see the hello node, and I can go to Patrick, and we have the Patrick generated. So it seems like a lot, right? Because, okay, now I'm having to tell it to write this head and to write this content, and I have to do this big if-else chain for every request made to the server, for every URL made to the server. Well, it doesn't end there. It's going to get more complicated before it gets easy. But I just want to show you guys what these small building blocks are actually doing, right? Does anyone have any questions so far? Cool. What's the next step that we should try? I mean, what's the next logical step of learning this framework? Render a page, right? I do not want to, maybe you guys are insane and you want to do this, but I do not want to do this for every single one of my responses, right? What other module did we bring in here aside from HTTP? The FS. And I said that stood for file system. That allows us to interact with the file system. So let's make an index.html. And let's get rid of the links for a moment. All right, and let's put in here, this is Node. Woot. Okay, we're very excited about Node. All right, so I have this HTML page. Let's say that I want that rendered on a new route. So again, how can I create a new route? Someone else? Just request that URL? Okay, all right, I'm just writing what you told me. Else if request equals what?
The name of the room.
Yeah, let's call it main, right? That's fair. So if the request.url double equal main, sorry, triple equal main, then we are still going to write ahead. We're still going to write something to it, and we're still going to write a response. But what I want to do is I want to retrieve that file, and that's the response I want, right? So we're going to use FS to traverse our file system for all of our files, for every static asset. In Node, you'll have to code routes. I'm not even kidding. For your HTML pages to tell it how to, this is the page to be rendered. You also have to do it for your CSS and your images. And any static asset, you have to tell it to go find this. And there's a way to create general solutions. The last assignment today is an optional. It's called static module or something along those lines. I'm forgetting the exact term. But basically, it's creating a general solution that almost works like a little bit of a library for you, where you can say, go get me any static asset. But until then, we have to write routes for every single resource on our page. And I'll show you what I mean by that when we get to the CSS portion. But what we want to use here is FS. And FS has a couple different things. I mean, I have this autocomplete, but FS, what we're going to do is we're going to tell it to read a file. Now, you will notice, if you have the autocomplete, you'll see read file, and you'll see read file sync. What do you think the differences are? One syncs or stinks? One is synchronous, the other one is asynchronous. Now, I'm sorry?
Asynchronous is a piece of files.
Synchronous, yes. Synchronous is just top to bottom, and if this takes 10 minutes, it takes 10 minutes. We're waiting. Asynchronous is go, 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 go. If this takes 10 minutes, you put it over here, and we continue past it, and then it comes back. So in terms of a Node server, right, where I want this to be as fast as possible, do you think I want to wait to read this file synchronously? No, right? That's up to the rest of the server, right? But if I just am curious or wanting to do connections here, I'm going to try to do the connections as fast as possible. I'm going to read this asynchronously. Well, if it's asynchronous, what do we need then? We need a path. We need a path to the resource. A callback function, right? Again, asynchronous should pretty much be intertwined with the idea of needing a callback function, because if it's asynchronous, something needs to happen when it's done, and that's the callback function, right? And then Hector mentioned a path. We do need a path to our resource. So we go from our current directory. So from app, we really just have index.html. And we will give it our callback function. And our callback function, in this case, will contain either errors or content. Right? Errors is an object that could contain errors if there were any. Content would contain, hey, the content, right? So what should we do? Let's assume that it's all going to work out properly. What would be the things that we need to do inside of this callback function, assuming the content is there? Yeah, so how did I already render HTML? Yeah, let's just grab this whole chunk And you'll notice with this one, it's just going to go right there inside of the read file callback. It's going to say, if the request was this, kick off this action. Start reading a file, right? And then when that file's contents are actually loaded up, go ahead and write the response and send the response back out to the user, right? When that happens. Until then, just keep waiting for requests. Just keep waiting and waiting and waiting for requests. But when the response or when content gets built and properly rendered, we can then actually write that information right here. You see how it's just logical progression, right? Now we're just trying to render a page. We have to tell the file system, go find us this file to digest it properly. There actually is one required argument I forgot. You also want to tell it the encoding type that file is, so the FS knows how to read it, right? And then if we've done that, when the content comes back, we'll go ahead and write that out to the user. To the response, I should say, and then return the response. Pretty complicated, right? To do something simple like rendering a page. And that's what you can see the frameworks do for us very easily, right? The framework says, okay, me and Jen are going to render this page probably the same way the majority of the time, right? Is there a more general solution for this? Absolutely, right? But Node gives you that granular control. That's why it's still so popular today. So let's try this out. That route was /main, and we get the HTML rendered back out. Cool? Something that we'd also want to do, we're not going to go too long today because it is sports day. I want to remind you guys. But something we also want to do in general when it comes to these callback functions is we want to, before we arbitrarily just write content there, I said to make an assumption, right? What was the assumption I said? Assume that it worked. Assume that content actually existed, right? That there was some stuff there. Don't be like me. Put your semicolons. Assume that content worked, right? But what we would want to typically do is something like if errors, and then we would do something, and then we would have an else and do something else, right? This would be our else, right? And if there were errors, maybe we can do response.writeHead. Maybe we'll send a 404, right? Not found, right? And then response.end. So let's see how that works. Let's try to render it again just to make sure it's still working. Still working just fine. And then let's try to make a small mistake here. Right? And we're going to see our 404 come back. That's not because some server knew automatically to send a 404. That's because I manually told it, when you screw up, send a 404 back. So you have the control to do all of that. Pretty cool, right? What's up? Yeah, I mean, these are all servers, right? It's okay to draw parallels to any other server you guys know. Yeah, that's why I was relating it back to the Flask stuff.
Just kind of like using a function to use that py file to display.
Yeah. The big difference is that that's MVC or MTV with Django. This is currently just everything in one place. So there's no separation of concerns. I mean, technically I'm routing here. This is sort of my view logic, if you will. There's no real distinction, and you can see how this could very quickly become this big, ugly, nasty file that I don't know what the heck is going on, right? And at first, that's the funniest thing about MVC. At first, it's like, why the heck are we separating this in so many files? And then you write over 1,000 lines of code and you realize, like, okay, I get it now. It makes a lot more sense. But yeah, no, that's definitely fair. It's just there's no MVC modularization. But now we've taken and read a file properly, and if it properly gets read, we then respond. Otherwise, we're going to go ahead and send a nice error out. There is some, one of the things too that you might send is the actual error. You could send that back out to the user too. So that's something that we'll see more with Express when we actually send the errors back out. The thinking is that rather than have an error actually throw, which means it just bubbles it to basically the top of your program to basically break your server. Well, you'll see your server crash in the stack a lot. But what you want to avoid that, and you want to just send the error back out to the user. Instead of just your server throwing up its hands and saying, this doesn't work, you want to say, keep going, tell the user, tell the person that requested it that it's not working, but don't let that error bubble up to the top of our stack right now. The last big concept I want to talk about is static assets, right? Because I mentioned early on that you've got to do literally everything when it comes to Node. So let's try to do something like, let's say I want to create some style. Styles.css or style.css, And I'm the best designer in the world. I'm just going to make everything green. Beautiful, beautiful website. And then index, all right, let's do link, and then rel style sheet and style.css, right? This is very similar to what you did way back in WebFun, right? Just say, go find that thing in this folder. Hey, the thing is right there in this folder, right? It should find it. But again, it's not in that folder when it's on the browser. It's coming from the server. This request will make a request back to the server, not to just look in a folder, but it's just saying, hey, server, I need this asset. Wherever it might be, you figure it out. So let's see what happens right now. Our page. Ooh. Okay, we hit a good bug. We have it hanging. Does anyone have a guess why it's currently hanging when I added that line for style CSS? It's looking for that link. Let's look at our logic. If the request was to index to do this, else if the request was to Patrick to do this, else if the request was to main to do this, did style CSS match any of those? No, so what happened? So we're down here now, and there's no response coming back, right? So that's why there's a current hang, right? It's just sitting there, there's no response, nothing happened. So let's put a final else statement first. Else, as in, didn't match any of my URLs. Else, let's just give them a 404. So at least in that case, we'll get a 404 now for style CSS, right? Again, you're in control of literally everything with Node. Got our 404 back. But does anyone have a guess how I could facilitate style CSS actually coming through? How I could send it to the user?
You don't have the class name, right? You can put in the index.
Oh, I just said to target everything. I just said target everything. Yeah. Yeah. It's not that the CSS isn't broken. It's more to do with all of the requests being made to the server. So far, we've made requests to //Patrick /main. Well, let's look at network real quick. Let's see if there's any other requests made. We see a request made to /style.css. Do I have a route set up for /style.css? We got to set it up. We have to set it up. So let's go ahead and kick this down for a moment. Else if the request.url equals what? Style.css. So even for your static, you have to set this up. And what should we do? Okay, so Hector's shaking his head back there. You will, I promise you will all eventually learn to love Node, but I swear today's going to be a tough day, and maybe tomorrow too, and then you'll see Express, and you'll go, oh my God, Express is so nice. Because Express is built on top of Node, and it says, you're probably going to respond this way with HTML. Let's just build a function that'll render something for us, right? So Express is that layer, right? But you need to know this stuff to figure out, to know what's happening with Express. So what should I do? Can I just return 200? Is that good enough? I got to read a file, right? I have to read a file. So, okay, who said that? Oh, you're way back there. fs.readFile. And let's follow the pattern from before. What was the first argument? The path, right? So style.css. The next was the encoding type. Well, it's still just plain old UTF-8. That's pretty much what most of the stuff we see on the web is. It's just UTF-8. Changes if you're like in another country potentially. Might be a different encoding type, yeah. But generally here it's UTF-8. What's the next argument? The callback function, right? The function to call whenever this elapsed, right? Whenever this actually finished. And we send it error and content, or errors and content. And I said best practice is to actually do your error checks, right? We don't want it to hang if it's not found. What's that?
The callback function, can we, instead of making an anonymous function, can you just make one because it's kind of the same?
Yeah, so that's actually one of the later exercises is to make a function that just works for any static asset. But this one will actually differ from the previous one slightly, so you'll see there is a small difference. But yeah, it's good to already consider what general pieces exist because, again, one of the main principles of programming is dry, right? We don't want to repeat ourselves arbitrarily for no reason. There's a much, much better way to go about loading any static. And you guys will try that challenge later today. But for now, let's kind of take the same pattern, the if errors, right? And then we'll do the same thing. We'll just response dot write head with a 404. We didn't find it, right? Or it broke, right? But we don't want to tell the user it broke. We'd rather tell them we didn't find it. Response dot end, right? Else, well, I'm still going to write ahead. We're still going to do exactly that. Response dot write head, and it's going to be a 200. Is the content type going to be HTML? It'll be text/CSS. Yeah, text HTML, text/CSS. Content type, and we'll do text/CSS. Okay, and we're going to write what to the response? Contents, right? And at this point, with this logic, are we certain here that content exists? We are, because we error checked, right? We said if there were errors to do this, and it would be done, the response would be finished. Otherwise, if there's no errors, there is content. It's one or the other with most of these functions. There's either error or data. And you check for the one and see if the other one's there. What's up?
And it's the read file method that gives the errors, right?
Exactly. These errors are the read file method. Yes. Yep. And then again, your callback will have to be dependent on whatever the function was that you sent it into, right? So the arguments coming in, the parameters you establish, depends on that one. Notice, the read file, right, we're sending it a couple of arguments and a callback function. We sent a callback up here that was two different things. Oftentimes it's two, because usually it's in the pattern of error, comma, good thing, error, comma, this. But here it's clearly not error, comma, this. There's both of these present at all times. So your callback really relies on what the function was that you sent it into. Perfect. So we're going to write content to it, and then we just finally response dot end. So when a request is made to /style CSS, tell FS to read the file. If there's an error, to kick out a 404. Otherwise, write the content using text CSS as content type, and then kick out a response. So let's actually see if we can do something. We can actually go to style CSS as an endpoint, right? It actually exists, but the better use is now our actual server is, or I'm sorry, all of our text is green. It properly got that CSS, right? It found that resource, and you can see the request being made. There was a request to /main, which did something. There was a request to /style CSS. So Node is gonna be pretty frustrating in the beginning. I'm not gonna lie. There's a lot to it. And this is honestly a sliver of Node. This is the main functions of Node, right? Render a page, or use the file system. This is pretty standard. We're quickly going to get past Node as soon as we get into Express, but I don't want anyone skipping Node. I want you guys to know what's happening under the hood, because when something breaks in Express, there's still Node underneath it, right? It might have been Node that broke potentially, right? So you need to know what's happening.
Node is like Lego.
What's that?
Node is like Lego.
It's like Legos. That's a really good comparison, because you get a kit of Legos and it's up to you of how you want to build it. There's a bunch of pieces, but you can do whatever you want with those pieces. Like FS, we don't technically need FS for this to work. We can just say, hey, just write HTML inside of all of these things. We don't need FS. But if we want to traverse a file system like a regular server would, we need FS. HTTP, it's pretty much we need that one. But there's different types of things we'd add. Middleware eventually. Body parser, which is a way to understand what request.body is, which holds our form data. Session. There's a plethora. There's so much more middleware that we would add to this at some point, or to our Express application. But it's very good that you compared it to Legos, because it works like that. Nothing's provided for you in Node. Cool? So I want you guys to give this all a shot today. How many people are done with the OOP section? I just want to get a let me see real quick. Let's hop in here. Main JavaScript. Let's see, JS OOP. How many people got to Ninja Class 2 yesterday? Okay. So the majority of us? Let's see. How many people got to Deck of Cards at the end of the day? A couple. Okay. So, not done yet? That's okay. These are really good for understanding OOP, but if you guys want to, as soon as you finish Ninja 2, it's okay for you to then move on to Node. I would like most people working in Node today. Well, I mean, you got extra, you just got extra knowledge. Sorry. This advanced section is really good concepts. Someone asked me about this earlier. It's really good concepts, but you notice every single assignment in here is optional. I'd say when you have time or if you're very bored this weekend, yeah, hop back. It's good to read. Please at least skim this at some point. It's really good stuff, but you don't have to do any of these assignments. So I would say when you guys are comfortable with OOP, when you finish Ninja Class 2, go ahead and hop into Node. And today's EOD goal, let's take a look real quick. I'm going to stop the video there, by the way.